So for Unit 2, Day 1 notes, I'm going to have you guys flip these words. So we need to flip these definitions. The input is your independent variable and your output is your dependent variable. For the rest of this unit, we're talking about functions. And in today's lesson, you're talking about if I give you a function, is that function linear or nonlinear? And here in this chart, we gave you examples of what linear and nonlinear are. So linear would be your straight lines. So here's some examples. Nonlinear would be curves, or in this case, like a V shape, but basically not a straight line. Okay. So if I look at these 4 examples here, I want to know which ones are linear, which ones are nonlinear. So this has a curve, so that would be non. Then we have a line, linear. Another line, linear. And then lastly, we have that curve, so that would be nonlinear. Okay, so that's how you look at it with a picture or a graph. Okay? But what if you were given a table of values, like example 2, and you had to basically just figure it out from the table of values? So when finding out if something is linear or nonlinear, we are going to always look at the y. Okay? So if we look at the y's here, from 3 to 5, how much does it increase by? Well, from 3 to 5, that increases by 2. And then if I go from 5 to 8, that increases by 3, because 5 plus 3 is 8. And then from 8 to 12, that's an increase of 4. So even though there's a pattern here, it's increasing by 1 more each time, this is actually nonlinear. And that is because these numbers here are different each time. If they were the same number, it would be linear. So let's look at the second example. From 3 to 6, we go up by 3. From 6 to 9, increase by 3. And from 9 to 12, you increase by 3. So this pattern is consistent, 3, 3, 3, same number, and so this would be linear. Okay, now, for C and D, you're looking at the Y going horizontally. Yeah, you can take your shoes off. Okay, from 8 to 10, you increase by 2. 10 to 12, increase by 2. 12 to 14, increase by 2. So, since that is the same number, this would be linear. Okay. For D, 0 to 1, that's an increase of 1. 1 to 4, it's an increase of 3. And from 4 to 9, it's an increase of 5. So those numbers there are different. So that would be nonlinear. Okay. For example 3, you are just taking these ordered pairs right here and rewriting them in here. So 0, 2, 1, 3, 2, 4, 3, 5, and then lastly, I bring down 4, 6. And then I'm just graphing those. So 0, 2, over 1 up 3, over 2 up 4, over 3 up 5, and then over 4 up 6. And ask us, determine if the function is linear or nonlinear. So by looking at the graph, that's a straight line, that's linear. And if I look at my y, 2 to 3 is an increase of 1. 3 to 4, increase of 1. And that happens to be all the way down. So that also tells me, since it's the same number, it's linear. So for the last one there, same idea, you're going to put those numbers, those ordered pairs, into the table of value. Okay. So 2, 4, 6, 4, 2, -5. Okay, so I'm going to go ahead and graph those, -5, 2. Okay, so this is a V shape, okay, which is nonlinear. And then if we look over here, like we're increasing by 2, we're increasing by 2, but then we are decreasing by 2. Okay, so since, yes, it is the same number, but here you're adding and here you're subtracting, that doesn't work. So in order for it to be linear, it has to be +2 all the way down or -2 all the way down, and it's not. So this would be nonlinear.